Discussion today, right now. And I'm going to have to keep it to 1 o'clock at the very latest because I've got 141 right after this. I'm going to sub for Professor Tripoli. So who's in 141? I just want to know who is. One person's in 141? I thought maybe more of those people were. So when that would be nice if you all put your hand on that request. Then I would know. Okay. So we'll continue on with our discussion of Michael and aftermaths and impacts at that time. But we're not going to be able to have a good discussion of the weather this week and today without talking about a little bit of Hurricane Michael right now. So some of this might be, unfortunately, somewhat repetitive for you in 141. But Pete's compiled, as he always does for interesting weather events, a series of really fantastic image sequences, movies of this stuff. So before it gets going too fast, here is the Yucatan Peninsula, northeast part of the Yucatan Peninsula, Isla Mujeres, Cancun, Cozumel. So there's where we are. And then here's the western part of Cuba. Okay, and you're going to see Florida coming up right about there. And here's the beginning of the convection on the 8th, which was what day of the week was that? That was Monday the 8th. Imagine this all happened from Monday to Friday. Unbelievable. So here it is in the infrared. So where it's pink, of course, are the coldest cloud tops, and then decreasingly warmer or increasingly warmer as you go to other colors. So you get a really nice picture, and here's the scale in case you're interested. This is about 190 degrees Kelvin on the top here on the far west coast of Cuba. And there goes the Yucatan. So my wife was down in Cancun until Wednesday of this week. And she said before she went, is there going to be any weather there? I said, no, not too much. And it turns out that was right. That turned out to be right. It didn't really do any damage here in northeast Mexico. But here you've got the storm organizing. By this time, this is now on Tuesday the 9th. By this time, everybody knew this was going to be a pretty intense hurricane, category 1 or 2, at least upon landfall somewhere in Florida. But we were not ready for what came next. And you can see that very deep, very cold cloud tops really encircling the storm with occasional moments or periods where that wasn't really true. It's kind of times where it's not really all the way around. But now you can see an eye begin to emerge by the time we get to about midday of Greenwich time on the 9th. And still this tendency for convection to swirl around the center. And there's the eye. Here's Florida, there's Tampa Bay. Okay. And now we're coming up on the Apalachicola Peninsula. And the forecast was pretty accurate for much of the week, saying it was going to go right through that peninsula or near it. If it went to the east, this would have been more swampy, less populated. Going to the west was much more populated and less swampy. And so the storm surge is a little bit better handled by swamp terrain than it is by non-swampy terrain. So everything was kind of in the wrong direction in terms of the impacts. This is now the half-minute data, Pete. It starts to slow down a little bit.
Images are every 30 seconds.
Every 30 seconds. So look at all the wave activity you can see kind of coming out of the center of the storm. Some of it is occasionally almost looking orthogonal. You've got these spiral waves, and then you've got on top of it evidence of pulses going across them perpendicular to that. The eye is extraordinarily well defined. Here comes Mexico Beach. It's right about here, and this is Apalachicola. And here's Mexico Beach. The eye comes over at about, I don't know what, 1:30 in the afternoon or something.
Yeah, 18Z.
And they had 155 mile per hour wind gusts. Sustained winds you'll see later on in 141 in that location of 129. So it's been a long time, actually, with the exception of just the last 2 years. Prior to the last 2 years, it's been a long time since actual hurricane force winds have hit anywhere in the mainland United States. It's really true that you get storms that are really intense, and just before they make landfall, you look around, you scour the data, and you find the greatest wind speed, sustained wind speed, is 72 or 73 miles per hour. Certainly that wasn't true last season, where, if you remember the pictures from Puerto Rico, it looked like a tornado outbreak had come over the island. It had just destroyed almost everything in its path. We're going to see some pictures from this portion of the state of Florida, especially over the next few days. You haven't seen some already that look exactly like that. And that's a sandy soil down in that part of the country. And some of those trees are really big. Tallahassee apparently is famous for its very majestic old oak trees. And many of those have just been ripped right out of the ground or toppled by winds. And Tallahassee's inland. So that is, it's been quite an amazing storm. It stayed a hurricane through some of its traverse through Georgia. And then it was a heavy rain event through the Carolinas and all the way, of course, up to New England. Today it's raining. We'll see in a minute. It's raining moderately in Boston, and the winds are in 15 to 20 knot range, sustained. Lauren.
Is this video like posted on YouTube or something that we can look at the one that you're doing?
It's posted on YouTube, and there's also a box link to the original MP4. It's big. It's like 420 megabytes.
Oh, wow.
But yes, it's out there, and I can get that to Greg or whoever. I mean, I think I sent it to the everyone at AOS list, but if you're not on that, or look for me after class. Or
Yeah,
whatever, I can get it yet.
He's the go-to person for this kind of stuff.
My email is poker, like the game, at aos.wisc.edu. So you shoot me an email, and I can get you the link.
Pete, while we're here, can we look at some of the visible imagery of the inside of the eye?
Yes, I just wanted to point out one thing on here, and if I can get to it, I don't remember what time it was, but there was a linear feature like this at some point. I think it's earlier than this. I don't remember if I can find it. It was just a really strange feature that was persistent, and I don't know what it is. I was curious if anybody had any ideas. If I can find it again. I don't remember the exact time that it was on there, but it's a linear feature that goes kind of like this, and it kind of persists through all this stuff that's going on. Yeah, kind of right here. What's that?
Oh, I don't know. That is interesting, isn't it?
And all this other
Yeah,
wave stuff is
all the wave stuff's going right across it. Yeah,
You know,
that's very interesting.
I don't know what
I
that
don't
is.
know. That's very intriguing. How long did it last? About half an hour?
Yeah, it would last a while.
Yeah. Very interesting.
Couple
Yeah, so-
hours perhaps.
You know, as Lauren's question about can we look at this on our own time, it's a good one because you can do this forever and you're never going to be bored. You're going to keep seeing new things every time you watch the animation of these. And this satellite data that we have now is just remarkable. So here's the inner eye. This is on Wednesday, midday. So it's going to make landfall right along this part of the coast. And you can see the sun's coming up and it's getting right into the center of the eye of the storm. Just incredible what you can see in there. All sorts of small scale vortices. It's no wonder there's a tornado threat when these things make landfall. Put a little friction in there and there's just going to be all kinds of spin up. But look at the beautiful structure inside that thing and how rapidly it's rotating in the lowest levels. And there it is making landfall with the giant eye coming right over the beach there and doing devastating sort of damage right in that location. It took a long time for the eye to fill in over land. Now the land down in Florida is low elevation, of course, and all that, but still, there's a lot of frictional convergence that should be forcing clouds there, and it takes a long time for that to actually cloud over in the face of that forcing.
Somebody from SSCC posted a really short loop as the eye came over the beach that you can actually, with the right contrast stretch, you can actually see the beach in the eye.
Is that right?
Yeah.
Wow. Just amazing.
Sims has a really excellent blog post. The Sims satellite blog has a great post on this, and a lot of these loops are linked in there as well.
Okay, yeah, it's got a place to go look there. And let's not forget that one of the biggest threats for such low-lying land is the storm surge. The pressure is 919 millibars in the center of that storm as it makes landfall. That's 100 millibars, 10% lower than standard sea level pressure. And so that's a mound of water about 3 meters high or a meter high or something. I guess it's a meter high, even just hydrostatically. And it's been kicked up by the winds. So you've got at least 3 feet of water plus whatever the waves are on top of that, inundating the land when that thing comes across. Because the water has just been sucked up, literally, out of the ocean. And so there's a big mound of water, a huge area of water that just comes flooding in. And then, as I say, put on top of it the big waves that are kicked up by the winds. And you've got devastation of the kind that people here are not used to. North Florida, the peninsula, especially to the west of Apalachicola, almost never gets these kind of strikes. In fact, didn't they say since 1851, since there's been records there of hurricane approaches and hurricane landfalls, there's never been one of this intensity in the Florida Panhandle. And let's face it, couple that with a governor in the state who has at least slightly encouraged over his term a lack of respect for science. And what do you think people are going to do if they're up here and they hear this? Get out of the way. They're not going to get out of the way. They didn't get out of the way. So the damage, some of it. So the damage that it's done is going to be worsened by that. It's just the way it is. We're going to find that out as time goes on, just like we do with Florence. It was a long delay for how bad the damage was. And of course, Maria was like that, where we found completely made up numbers to make it seem like it wasn't so disastrous. Anybody in this room who'd seen pictures of the devastation over the hills of Puerto Rico last September knows you don't usually see that with a hurricane passage. It doesn't happen. It doesn't look like that unless it's a catastrophic storm. And of course, the numbers caught up with the lots.
That's
So-
just having issues.
What are you looking for
Now, I
now?
had another visible, a wider scale visible. It's not playing right, so I'm not sure what's up with that.
Well, maybe we'll leave the discussion of Michael at that point and just kind of remind ourselves, oh, look, we haven't seen the radar. Okay, let's look at the radar.
This
Well, we're
starts,
looking at the radar.
0 on the 9th.
So a day before landfall.
Yeah.
Not useful to have it earlier than that because you don't see anything. But boy, the eye came into focus closely into the coast. This is the, I think the radar up in this portion of the state, and then it goes racing northward. This storm moved fast throughout its entire history. And look at how well structured it stayed. You know, there's no eye anymore, but there's obviously a center of circulation of that thing all the way into the Carolinas. You'll see it today when you look at the current radar. It's still obviously circulating around the center. That's of small scale over New England. So pretty incredible storm. And as I say, I think we're going to learn more. Maybe Shane Hubbard's going to give a talk on Wednesday, I think. Maybe it's Tuesday afternoon of the coming week, Tuesday, after I know I have to miss it for the class, at 2:30. And that's going to talk about Puerto Rico before and after Maria. And he works for FEMA. So he'll have something interesting to say about that. If you can make that 2:30 on Tuesday.
It's the CPEP seminar. I think there's posters in the hall. on it.
Yeah, that's right. It's posted around. And you'll be able to, I'm sure he's not going to be able to resist saying something about what we know between last Wednesday and Tuesday afternoon about coastal Florida in the Panhandle from Michael. So the numbers will be rolling in for FEMA, and they're mobilized, of course, to do what they can to help people down there. So let's leave Michael and go instead to the national satellite image and start our discussion. I don't think I have it loaded up, so we'll just pick it up again. So here's our national image, and you can see the circulation of Michael is still intact off the coast of the middle Atlantic in New England, and then heavy clouds in the Gulf of Maine, Massachusetts Bay. We'll see that it's raining in coastal Massachusetts right now and has been for some of the time during the day associated with Michael. During the week, we had a weather disturbance coming across the central United States, an upper level trough, and a strong baroclinic zone across southern Canada, with which Michael now begins to interact. So some of this cloudiness over maritime Canada, well to the east of Newfoundland, is tied into that interaction. So maybe we'll be able to see that in some of the diagnostic maps that will show. Very cold air coming down off the high latitudes of the continent through the Labrador Sea. You can see the open cellular convection, and you can see swirls in the lee of Greenland itself, which is a place where it's really stormy this time of year, and of course the air is frigid as it comes across relatively warm ocean. Good thing this happens, because this is one of the things that generates the North Atlantic convection. Cools the surface water, which sinks, and that's part of the giant thermohaline circulation that also influences the Gulf Stream. So that's a really important part of the poleward export of energy that needs to be done by the ocean. So here is the central United States of broad cloudiness. If you look at this map, you'd say to yourself, well, it looks like there must be some sort of cyclonic or weak cyclonic disturbance over the northern plains with a trailing cold front. Wait till you see the surface map. It doesn't look anything like that. And there's some really cool little nuggets of interesting diagnostic power that we can illustrate based on the weather in the central plains of the United States today. So it's kind of interesting from that perspective. It's not particularly interesting weather, but it's interesting scientific study that we can make. So let's follow this up by taking a look at the radar over the central U.S., just to set the stage. So here's the precipitation that I'm talking about over central Missouri and spreading into central and northern Illinois. So this is broad patch of precipitation. Now you might expect that you'd see that's going to be tied to some, as I said, some frontal type cyclone back over the Dakotas and Minnesota. This might be the trailing cold front. You'll see that's absolutely untrue. And characteristics of where this heavy or moderate precipitation, but persistent precipitation is falling is very noteworthy. So we pay attention to that when we go to that. Okay, after this, let's take a look at some of our super peats. And we'll start at 500 millibars. Thanks, Pete. So remember, it's raining across central Missouri and Illinois. There's an upstream of that. There's a really sharp region of curvature right over here on the central plain states, Nebraska, Kansas, and South Dakota. And it's pretty chilly aloft in the sort of central axis of this trough. It's minus 28 at Sioux Falls, minus 25 at Minneapolis. So pretty chilly air at upper levels, with a sharp trough just to the west of the region where it was precipitating. So that's interesting. Broadly speaking, though, that trough is in broad northwesterly flow. And let's see what it looks like at 300 millibars. So here's 300. We have kind of a jet stretched across the very region where it's precipitating. There's not really such an obvious exit region, so-called, of the jet. The flow is decelerating kind of generally across a wide region of parts of our own state, all of Illinois and parts of Kentucky, for instance. The acceleration into the jet core is a little bit more localized, so one might imagine ascent over the Colorado Rockies and some descent being forced, or other way around, ascent over New Mexico and the Panhandle of Texas, and some descent over the Colorado Rockies as a consequence of the along flow acceleration that forces ageostrophy in the entrance region. But you still see that kind of sharp upper trough, local but fairly sharp upper trough over South Dakota and Nebraska at 300 millibars. No clear evidence of Michael, except perhaps the very warm temperatures at 300 millibars over this broad region of the mid-Atlantic and southern New England. It's minus 26 at 300 millibars. It's pretty warm. And let's go back to 500. I don't think I drew any attention to what was happening at 500 millibars at this level. And you see, again, a little pocket of warmth and a geopotential height trough. That's where Michael is. So this is the centroid of that warmth that we even saw at 300 millibars. The temperature is minus 2 at 500 millibars right there. So that's pretty warm, okay? It's not anywhere near that warm. Well, you have to go all the way down to the Caribbean before you can get close to such warm temperatures. And even there, it's colder aloft than it is right in the center of what used to be Michael. Michael's hanging on. These things have some resilience. So let's see what it looks like at 850 millibars. So at 850, really complicated structure along the East Coast. So first, here's the cyclonic disturbance that was lurking to our north much of the last half of the week. And here's the strong baroclinic zone that was tied to it and extending to its east as a warm front, but it was well north of us. So we had those days where, we had rain on Tuesday and Wednesday with temperatures in the mid to high 70s, dew points in the mid 60s. And then it suddenly transferred a little bit, got cooler, and we'll see why in just a second. But that baroclinic zone had raised poleward of us early in the week, brought us back to summertime and relative warmth and humidity, and that was tied to this cyclone. And then it also had a pretty strong cold frontal baroclinic zone associated with it that cooled us off by Wednesday night into Thursday. But look at what's happened as Michael has run into that trailing cold frontal zone. Look at how intense the baroclinic zone is, right along the middle Atlantic coast down to the Appalachians. So we have plus 16 on the warm side and minus 1 on the cold, or plus 1 on the cold side across this really strong gradient region. And the circulation that remains of Michael has found its way to almost the exact location of that intense horizontal temperature contrast. Undoubtedly, that contributed over some period of time in New England to locally heavy rain amounts, because you think about the circulation being counterclockwise around this disturbance. So there's pretty strong differential warm air advection in the Gulf of Maine, and then cold advection by the large synoptic scale flow to the west on the western side. So there's strong phreноgenesis along this baroclinic zone. And air on the warm side is really tropically moist. And so pretty heavy rains were falling in that location as a consequence of that juxtaposition of these two features. We're going to trace Michael, or what remains of Michael, further across the Atlantic for a period of time. It really develops nicely along this baroclinic zone, but then it migrates across and dies an ignominious death, like the namesake of October 12th in the Iberian Peninsula. And you'll see that later on. Okay. Meanwhile, let's not forget, one more thing, Pete. Let us not forget, there is some pretty chilly air lurking to our north. There has been all season long. It's been really cold over the western part of the northern hemisphere, and that's where we are. So we've got temperatures in the minus teens in far northern Canada, archipelago, and even into the central part of the country of Canada, we have temperatures minus 5 to minus 9 in Winnipeg. Or, I mean, not Winnipeg, but in the central part of Ontario. So it's really cold in central Canada, and it's been lurking for quite some time for us. So do we see that, and do we see the current conditions as we have outside persist, or do we see a return of southwesterly flow? That's kind of a fundamental forecast question for us, and we'll see as we go forward. Okay. All right, we haven't looked at the West Coast. Why don't we take a quick look at the West Coast satellite image, then we'll go to a surface map and do a little search around the country. for that. So here's the West Coast satellite movie. And one of the reasons it's been so persistently cold in the eastern part of North America for this whole last several weeks is there's been a persistent ridge right off the West Coast. That's finally now, seemingly, for the first time in a while, it was almost not so obvious to me anyway that this was being sustained by cyclogenesis in the Bering Sea region, let's say, but it is now. So this is a pretty decent cyclone. Big cloud head. Air, you can see in the the way in which the clouds are moving, it really one gets a sense the air is coming from the subtropics and then filling in this big ridge over Alaska. For the last 6 weeks or so, it's been way abnormally warm over the North Slope of Alaska, both in this location and then over towards, farther to the west. Something on the order of 5 or 6 degrees at 850, so way above normal. And that's probably had an impact on how long some of this open water has stayed open. So there's probably going to be some feedbacks on that downstream. I don't know what they might be, except for snow along the northern coasts, because you have a longer period of open water here. But it's been really, really warm in the lower troposphere up over the north slope of Alaska for the last 6 weeks at least. And that doesn't hurt if you're trying to drive ridginess at about 130 degrees west, which almost always implies troughiness further to the east, and we're getting cold and staying cold as a consequence. But no really nicely developed storms in the immediate west coast region of the United States, with the exception of the west coast of Alaska. That's a pretty intense storm. Okay, let's take a look, Pete, at the surface map, the large surface map, and we'll start looking at our own location, if we could. So pretty chilly. The roof, I think, will be closed tonight at Miller Park, probably tomorrow also. It's going to be, in the 30s by the time the game's over. So if you're walking back to your car on Blue Mounds Ave, James, I don't know where you park, but if you're doing that, it's going to be a cold walk.
John, is that snowing right here in Illinois?
Yes.
36 over 34.
Is that Springfield?
Yeah.
That's Springfield.
Is it?
Or close to it anyway. Just around Springfield, 36 over 34 light snow in Illinois. So Illinois beats us again. They beat us a lot, but they beat us with snow, first snow of the year in this part of the country, I think. So that's pretty good. And then cold rain in a lot of other places. It's not usually 45 and light rain in mid-October in St. Louis. That's downright cold. And we have temperatures at or below freezing over a large part of the northwestern portion of Minnesota, where the skies are even clear. It doesn't even matter that the sun's out, it's still below freezing. And then close to or maybe just above in some locations in the central part of our state, and we're not very far away from it ourselves. So a pretty chilly day, and that's likely to persist. And as you can see, widespread reports of rain across the central United States. St. Louis, central part of Columbia is further to the north. Moderate rain even down near Shawnee, and light rain in Kansas City, same in southern Iowa. So this whole region is precipitating in a couple of places, at least one, showing snow. Amazing, unbelievable. So let's look at the pressures in there too. Pressure at St. Louis, 1,018.8. 1,018 southwest of St. Louis, 1,017.3 in Kansas City, where it's snowing, 1,018.9. And then go to the north, pressures are lower. Go to the west, pressures are about the same. To the south, they're lower. So there's a region of high pressure in which this precipitation's falling. That's just flat weird, right? I mean, that's weird. We got to try and figure that one out. So that's going to be the mystery part of the discussion today, what's going on here. And I've already mentioned it's snowing also in Sioux Falls, look at that. Or is that Aberdeen or Sioux Falls? I forget which one it is. Anyway, it's in South Dakota. I already mentioned the upstream trough over the High Plains states. And this precipitation is conspicuously to the east of that. So let's see if we can't make some sense of that when we go to, let's go to a 6-hour forecast from the 12Z run, if we could, Pete. And we'll start at the surface, just to see what the forecast is. So here's the forecasted precipitation at about the same time as we're talking right now, generally in the same area as it's actually occurring. Not surprising. 6-hour forecast today ought to be pretty good. But look at the pressure. Look at the distribution of sea level pressure. It's right at the center of an anticyclone, a modest anticyclone, 7 or so millibars above standard sea level pressure, but right in the center of an anticyclone. You put that on at a final exam, even at the 300 level, and someone's going to say, well, come on, you made this up. You're being a jerk. No, not true. So let's go to 500 millibars at the same time. So here's the 500 millibond map at exactly the same time, same region. And there's the vorticity maxima right on the southeastern portion of Nebraska, northeastern part of Kansas. So I'm going to leave the pointer right there in the maximum of the vorticity. Let's go back to that surface map. That's where the vorticity centroid is. Thermal wind is parallel to all these thickness lines, and it's fairly intense. That's a pretty strong gradient of thickness. Downstream of in the thermal wind sense, there's positive vorticity advection. The vorticity is maximized right here by the thermal wind. That's PVA by the thermal wind. On top of a weird anticyclone, and it's precipitating directly and probably uniquely in response to that force. And that's the most fundamental way to diagnose vertical motions in the QG system. And it's 70 years old now. And so it's perfect example of that occurring today in places where the pressure is higher than anywhere within hundreds of miles. Isn't that interesting? And that's been in the forecast for 2 or 3 days. I was hoping it would actually come to this point and just about verify, which it is now, because it's been there since the first time I saw it was Tuesday afternoon. I thought, what a perfect example of PVA by the thermal wind. And so isolated, but there it is. Isn't that neat? And let's go back to the 500 millibond map. Earlier in the week, the features were a little bit more dramatically isolated, but even in this map, you see how isolated they are. Here's the circulation for Michael. There's the one associated with our mostly rain, a couple of snow observations in the central United States. Look at that localized vorticity maximum. That's extremely localized here in southern Alberta. So there's a whole string of really small scale, but mostly isotropic vorticity features in the map today. And one of them has a particularly impressive consequence over the central US. I'm not sure what's going on here with this negative, this minimum, but up sheer of that in a thermal wind sense, there's PVA, and there was rain also going on over the border of Arkansas and Oklahoma. So that's the same type of forcing. Okay, broadly, see a tendency for northwesterly flow all the way from far northern Alaska down to the central United States. We'll see in the forecast that tends to persist, at least for the next several days, without much interruption. Probably means we're going to have these really nice autumnal conditions persisting as well. But let's take a look now a little bit more at Michael and go to the surface analysis again, the 6-hour forecast beat, if we could. So this is the situation as it exists now, but this was a 6-hour forecast. The heaviest precipitation is offshore, it looks like. I think we saw that on the radar too, although the radar in the Northeast is a little bit off the edge of the broad national mosaic. But the heaviest precipitation is right off the coast, and that is a function of being on the warm edge of this broad baroclinic zone where it's being phenogenetically forced by the circulation around Michael, in combination with the circulation around this weak low over Hudson Bay, the one that's been looming to our north all week long. So very heavy precipitation. The amounts, these are 3-hour precipitation amounts, accumulated something like 1.5 inches on to the order of close to 2, just offshore where everybody's fishing for haddock and cod in Georges Bank. And then there's heavy precipitation in this portion of the warm frontal structure that was tied originally to this storm is now being influenced also by the circulation around Michael. Counterclockwise as it is, it intensifies this baroclinic zone to the east of the Maritimes and south of Newfoundland. So that's pretty heavy precipitation. All of it in the form of rain. It's not cold enough to snow until you get up well into upland Quebec and maybe northeastern Ontario. So that's Michael still producing enormous amounts of precipitation after a whole week almost of existence. Pretty incredible. Aside from Michael and this odd precipitation in the central US, the rest of the country is enjoying a pretty nice day. This is Sergio, I think, right? Making its transect across the Baja California and into the Gulf of California, and it's precipitating heavily over the Gulf and even a little bit in southern Arizona, which is unusual, of course, for this time of year. They're past the monsoon, usually by mid-October. And this is directly a function of an odd path for Sergio, following Rosa, maybe a week or so ago, maybe 10 days ago, large.
Can you comment on the fact that a couple days ago, northern Arizona got like 3 inches of snow?
I have not followed it enough to make any reasonable comment on that, so sorry, I can't, no. I don't think it had anything to do with the tropical disturbances to itself, though, I could say that with some confidence.
I think there was a low level or an upper level trough that was pretty potent before it swung.
Oh, is that right?
I remember right,
Okay.
yeah.
Okay. Yeah, I hadn't seen that, so I hadn't noticed that. Okay, let's start to look a little bit, not in the forecast yet, Pete. I would like to take a look at some, let's go back to our bar and remind you what I had up there. Yeah, first we'll do this. Let's just take a look at the omega. Let's go all the way to 12Z. I think it's in now. It might not be. Let's see. My page is so old and dinosaur-like that you have to do it this way. Is this the U.S. or Central North America? Yeah. Let's try the 6-hour forecast. That's valid at the right time. Okay, so here is in fact, let's go one more, go back to another one. Let's go to the Trendberg. This is purely the PVA by the thermal wind, just the one that I referenced. And sure enough, remember the vorticity maxima was right about in this location over southeastern Nebraska and northeastern Kansas, and then the thermal wind is parallel to these dotted lines. So downstream of that in the thermal wind sense, there's a region of ascent. And that's a pretty broad region of ascent. It's weak, but it's broad. This is the actual inverted omega. And then the descent upstream of it is also broader than one might expect. So anyway, much of the precipitation that we saw on the radar is falling within this envelope of weak upward vertical motion. So one doesn't have to only trust the theory. You can actually invert the equations and get the answer and see that they're pretty much right on. And then here's the heavy precipitation associated with ascent, at least the quasi-strophic ascent, is off a little bit to the east of where the forecasted heavy precipitation was at this particular time, but it's roughly in the same spot. It's finally drying out over New England because there's some synoptically forced descent, at least, in that location. Okay, that's all I wanted to show on that.
I wonder if we should build a light over there. It's pretty dim.
Oh.
Be easier to see if it's.
Yeah, okay, yeah. So that maybe looks a little better, but it tells the same story. Okay, so let's follow Michael. That's very clear. Why is it so sharp? That's fantastic. All right, let's follow Michael. Let's go back to the saved pages file, so I can go up there. We'll use Alicia Bentley's analyses or forecast maps and analysis maps from the GFS. She makes these beautiful maps. Alicia's a former graduate student at Albany. Now she's working at NCEP somewhere. I forget where, but really fantastic young scientist. So let's back up a couple times. I think you hit the back arrow to go back. So now we're not in current time, we're in past time. These are 48 hours ago when, right there's good beat. You can go a little bit ahead, 48 hours ago. So there's Michael in the sea level pressure field of the global forecast system model at 12Z on Wednesday. So several hours before landfall. And then the black lines are all across the map are sea level pressure. The shading represents 250 millibar wind speeds, and they're kind of shown here on this scale. And then the blue and red lines are 1,500 millibar thickness. And they change color at the 540 decameter thickness line. So that's characteristically a rain snow boundary, 50-50 rain snow boundary. So here is the baroclinic zone that I mentioned that was lurking to our north. It wasn't just over us in the eastern part of North America, but it went all the way to the Canary Islands. Incredible. And this was pushed northward as this cyclone came to our west and made us really warm on Wednesday into Thursday. And then when the baroclinic zone, or Tuesday, Wednesday, and then when the baroclinic zone on the west side of the storm went past us, as the storm went up that way, we got colder. And so we're into that cold, we're into the depth of the cold air that's back behind this cycle. Watch Michael. So let's go forward by the same thing using a forward keystroke. So there's Michael making landfall, and I think these go every 6 hours, so we can go ahead. And it's traversing the Carolinas through the middle Atlantic states, and now we're going to get to about 0, which will be the current time, and that's now, and the storm is just off shore of New England, and you can see we are in a region of pretty strong geostrophic cold advection throughout the lower half of the troposphere, and that's keeping us nice and autumnal. And then let's keep on going. Watch Michael. That's clearly Michael going south of Nova Scotia, and then south of Newfoundland. And this is the time where along that baroclinic zone that was preceding it, it starts to look like it's really taking off as an extratropical disturbance and getting stronger. But watch what happens. Even then it gets a little stronger. Still pretty strong. Then it's going to start to weaken after this point. Here it comes, sliding southward, as I said, into an ignominious death over the Iberian Peninsula. It's dead by the time we get to 72 hours from now, Monday morning. That is the end of Michael. And it's replaced by, too bad our real Michael isn't here, it's replaced by a basin-wide circulation associated with this modest extratropical cyclone. So there goes Hurricane Michael into North Africa. Actually, back to hurricane photographs. No, not this one. This is Caribbean storm, so it's not true. And meanwhile, you can see in the forecast, we remain in the blue thicknesses, cold, cold, cold. And with disturbances coming down in that northwesterly flow, here's one here on the western shore of Hudson Bay that will kind of slide to our south as well. So all the way through the weekend, we stay chilly, not desperately cold, although we'll have our first widespread frost tomorrow night. If we don't have it in many places tonight, but we will tomorrow night. And so that's probably the end of the summer for us. No doubt about that. It's hard to recover from polar air in the mid part of October. So one more thing I want to show. Yeah, we'll be on pretty good time and time for questions. One more thing I want to show is a map that I saved. It's right here. So I'm looking at the 850 millibar -5 isotherm and its aerial extent every day. And here is, from the last 70 or so years, the long-term daily average. And it's not surprising that from September 1st to the end of December, there's a systematic increase in the aerial extent of -5 degree air at 850 millibars. The hemisphere cools, the cold air spreads, and that's what we're seeing there in the blue line. This is the time series from this year up through yesterday, October 11th. And so the first few days of the month of September were about on average, but it's hard not to be, I suppose. And then we've been consistently below average, accruing a deficit of coldness, you could say, all the way through much of the first 41 days since September 1st. So I want to update this every couple of weeks just to see how we're doing. And I'm intrigued, although it's increasingly clear to me, not conclusively yet, but increasingly, that what's happened in the past 2 weeks means nothing for the hemisphere in the long term for the whole winter. And so there's no such thing as a point at which you can declare this winter is going to be warmer than normal, because it's already been so warm up to December 1st. I don't think you can do that. And I was hoping you could, but I don't think you can. But nonetheless, it's interesting to note we've been successively warmer than the long-term average for every single day for much of the last 5 weeks. And I think that's all I was going to say about this. So I don't think I had anything left. This is going to be for 141, so we're all done with that. So I think that's all I have for the discussion today. Are there any comments or questions?
I was
So-
curious, I don't know if you know the answer to this, but, so there's remnants of Nadine that's currently in the Atlantic that's about to hit Portugal. They've issued like tropical
Yeah.
storm.
Let's go back to there. We can see it on these maps.
And then,
And go back, Pete, sometime.
so you can see
So there's Nadine,
Nadine making landfall as tropical storm in Portugal.
right at that time, which is
Yeah.
Sunday at 0Z.
And then Michael, it's not really tropical anymore, but
Right.
still remnants of are hitting Portugal. How frequent is Portugal hit?
That is a good question. I know in 2005, there was a pretty active hurricane season in the Atlantic, as we all know. That was Katrina year and Wilma. But there was a whole extended October hurricane season into early November that year. Hurricane Karen, I think, was in November of 2005. And so those storms, the ones that sit around for a long time in the central Atlantic, do seem to find their way to the Iberian Peninsula. I don't know how frequently that is, but it's not unprecedented. It's not like seeing the hurricane off the coast of Brazil some years ago, 2003, or anything like that. But it's a good question. And is it substantial enough in terms of its frequency to actually influence October climatology in the Iberian Peninsula? I don't know.
It's actually Leslie, not Nadine.
Oh, that is?
Yeah.
Okay.
Thanks, Austin.
Yeah, so I don't know how often that happens. But the Portuguese are a seafaring people, so they probably certainly know how frequently the tempests toss them in October. And I don't. So. Any other comments or questions? While we're making predictions, James and I, and I'm sure Kate will join, and Pete will too.
They just released their 25 man, but I haven't seen it yet.
Okay, so that's
Daniel
new.
replaces Broxton.
What's that?
So Daniel replaces Broxton.
Otherwise the same.
That's a good move. So Cedeno replaces Broxton, another arm for a bat. And it looks to me like the Brewers are going to win this series in 6 games.
Brewers in 6.
I think that's
It'd be nice
gonna
to have them
happen.
celebrate at home.
Yeah, I think that's what's going to happen. So if you can, do what you can to make that happen. It's a pretty exciting time for us. And you know, the other thing is, I'll say, just parting thing about baseball. this Brewers team, it'd be wonderful if they won this year, but if they don't, they'll be back next year. So everybody knows that. Everybody knows that. So it's gonna be exciting. All right, I'm done. Pete, thank you for driving and for these fantastic movies of Hurricane Michael. And we'll see you next week. Next week is gonna be special because it'll be, our alumni will be here. We'll have free pizza, so make sure you get here a little bit early. And it'll be really fun. Hopefully the weather will be exciting and it'll be something really interesting to talk about. So, all right, see you then.
Thanks, John.
Dodgers also swapped with Matt for a left-handed arm.
What'd they do?
Urias.